Welcome back, guys. Let's look at the functioning of the eye, how the eye focuses in dim light, in bright light, and in far distance and near distance. Then the key words here, we've got pupillary mechanism. You remember, it has to do with the pupil. So here, pupillary mechanism is the ability of the pupil to change size for clear vision when viewing image in dim light and image in bright light. The next one, we're talking to the convex. It's a shape. But what type of a shape? It's a shape that curves outwards, meaning it's thicker in the middle than at the edge. Then we've got another shape here, concave, which curves inwards. It's the opposite of the convex. It curves inwards, meaning it's thinner in the middle than in the edges. So let's look at accommodation. Accommodation, we are looking at the first functioning of the eye. The ability of the eye to accommodate, meaning to see images far and near. So we're looking at the image less than 6 meters, we refer to that image as near. And distance, we're looking at the focusing an image more than 6 meters. So what is happening in that case? We're talking the ciliary muscles. That will do what? That will contract. And then the suspensory ligaments. That will do what? That will slacken, meaning they will become a little bit loose. Then tension on the lens decreases because the suspensory muscles are now loose. Then what happens to the lens in that case? Then the lens will become more convex, which means the lens will bulge. This will cause the light rays to bend more. Then a clear image is focused on the retina. Then what about distance vision, more than 6 meters away? What will happen to the ciliary muscles? They will relax. And then what will happen to the suspensory ligaments? They will tighten up. And what will happen to the lens? The tension of the lens will increase. Then when the tension of the lens increases, what happens? The lens becomes less convex or flatter. This causes the light rays to bend less. And then what happens? A clear image will form in the retina. So this is the opposite of the functioning of the eye in the situation where the image is far and the image is near. But we're looking at the ciliary muscles, we're looking at the suspensory ligaments, we're looking at the lens, what happens to the shape of the lens, and to whether it becomes convex or more convex or less convex, and the image becoming clear. The second functioning of the eye, which is pupillary mechanism, where now we are going to look at what happens to the pupil when you're looking at the image in bright light and in dim light. Then we're looking at the bright light this side and the dim light this side. Then we say the radial muscles cause the iris to relax. Then the circular muscles of the iris will do what? Will contract. When they contract, the pupil constricts or becomes smaller. Then if it is smaller, obviously, amount of light that is entering the eye will be reduced because of the constriction of the pupil. Then this diagram shows you that here we've got the pupil that has been constricted because of the radial muscles and the circular muscles, and because you are focusing on an image in bright light. What about in dim light? Still, we're talking to the radial muscles. But in this case, what do? They cause the iris to contract. Then the circular muscles of the iris will do what? Will relax. When they relax, then the pupil widens up or becomes bigger. So in that case, the amount of light that will enter the eye, the pupil will increase. So the diagram here shows the bigger or the dilated pupil, because now you are focusing at the image in what? In a dim light. Now we're looking at the questions, because we saw two functioning of the eye, pupillary mechanism and accommodation. It says, name and describe. Verbs are important. What are you naming and describe? Process, which does what? Which involves the iris controlling the amount of light entering the eye when a person is exposed to what? To bright light. Once you take into bright light, now we know it's pupillary mechanism. Then what will happen? We talk into, it said, name and describe. We naming the process. The process is pupillary mechanism. And what is happening there? The circular muscles of the iris will contract. Then the radial muscles of the iris will do what? Will relax. And then the pupil constricts, becomes smaller. Then when it is smaller, we know less amount of light will enter the eye. So the amount of light entering the eye is reduced. The next question, question 2 and 3, refers to the diagram which shows two eyes. Eye X and eye Y focus on an object at different distances. Distances, accommodation. Object A and C were 3 meters away from the eye. Object B and D were 8 meters away from the eye. So here's the diagram. We are told about the distances. The 3 meters is less than 6 meters. 8 meters less than 6 meters, more than 6 meters, which means object B and object D are far. Object A and object C are near. So this is the diagram. You study the diagram. Here are the objects. We see A is here, and then we see here is C is here, and then we know they add 3 meters. And we've got object B and object D. They're 8 meters away from the eye. So let's look at the questions based on this diagram. Question 2, it says, write down the letter of the object that does what? The object that IY is focused on. IY is focused on C. And then IX is focused on B. Then we move to the next question. Name the eye defect, which results in the inability of the eye to focus. Inability of the eye, Y, to focus on the object. So we're looking at that defect as long-sightedness. Then it says, Name the type of the lens used to rectify this challenge of long-sightedness. So you use the concave lens. The next question, it says, identify and describe the process that allows IY, this eye, to form a clear image on the retina. So we're looking at the process as accommodation, and what is happening there? The ciliary muscle contracts and the suspensory ligament slackens, and the tension on the lens is decreased. Then when that happens, the lens becomes more convex. That will cause light rays to bend more. So if the light rays are bending more, a clear image will be formed on the retina. Keywords here, short-sightedness. It occurs when a person has the ability to see near object but cannot see distance object clearly. Then when we talk to long-sightedness, it occurs when a person has the ability to see distance objects but unable to see nearby object clearly. Astigmatism is a blurry vision that results from curves in the cornea. Cataracts occurs when the clear transparent lens becomes cloudy. So these are the defects of the eye: the long-sightedness, astigmatism, including the short-sightedness, and cataracts are the eye defects. So we've got the diagram there that shows the short-sightedness or myopia. So we say, when we look at this diagram, it is an eye that has got this type of a defect, which is a short-sightedness, where now we see the eyeball that is too long, and then the cornea being too curved. Then, for the length of the eyeball, and then the inability of the lens to become less convex. Then when you look at all this, we're talking the short-sightedness in a case where the eyeball is too long, where the cornea being too curved for the length of the eyeball, and then again the inability of the lens to become less convex. So what would be the treatment for short-sightedness? It will be glasses with concave lens or lenses that are concave. Guys, the rest of the part of the eye and the functioning of the eye, you can still revise on your own. This brings us to the end of our lesson. Thank you and goodbye.